Good morning friends. I Gaurav Murgare. Today we are going to discuss the topic reason of convergence which comes under the Z transform. In my first lecture I have discussed about the Fourier transform and the Z transform. Some basic concepts about the Fourier and how the Fourier can be further described by the Z transform. So for the concept of ROC, it is very important if we'll calculate the Z transform for any signal, the ROC for that signal has to be mandatorily calculated, or we should know, because the ROC defines where the signal exists. Any transfer function for any system xz is represented by pz upon qz. P is the numerator term and Q is the denominator term. As we all know that it must be a polynomial function or any linear expression or any function of z in the form of z, maybe in the positive power of z or in the negative power of z. So the value of Q will define what are the poles, and the values of the numerator, the roots of the numerator, are called as the zeros. Let's start with an example. Here we all know that xn signal is a to the power n un. For that we have calculated the Z transform as z upon z minus a. We have calculated this in our previous video. So ROC is defined as mod of z is greater than a. I'll clearly tell you that if we'll substitute z minus a is equal to 0, that means z is equal to a. Okay, and if we'll substitute the z value of z as a positive or greater than a, then the whole term will be positive. But if we'll substitute the value of z lesser than a, then the term will comes out to be a negative, which is not should be the condition of the ROC. So for this question, a to the power n un whose z transform is z upon z minus a, ROC clearly defined as mod of z is greater than a. So for this value we will see the circle of radius a, and the shaded portion, with that means the region greater than a, is shaded with the dark color. This is the ROC for that sequence. Again, we also know that if for the left hand side sequence minus a to the power n u of minus n minus 1, the z transform will be the same, z upon z minus a. But the ROC here is mod of z is lesser than a. So for here we are seeing that the region lesser than a, that means the circle having the value lesser than a, is shaded. Suppose we are having any two terms, 1 by 2 to the power n and minus 1 by 3 to the power n un. For that we know that z upon z minus a is the answer for a to the power n. So for the z transform of this first term is z upon z minus 1 by 2, and for the second term z upon z plus 1 by 3. The answer will be z minus of minus 1 by 3, which is resultant to z plus 1 by 3. If we'll solve this term, we'll be going to get this term 2z up into z minus 1 by 2, and the denominator are the same. So for these three things, for these terms, we know that we'll calculate the ROC from the denominator side. So here the values are z is equal to 1 by 2 and z is equal to minus of 1 by 3. So for that, if we'll calculate, the minus 1 by 3 is located here and 1 by 2 is located here. So the value which is greater than the ROC, that means the value is greater than 1 by 2. So 1 by 2 circle is the highlighted portion for this. And another question, here having the two-sided sequence. This is the right hand side sequence and this is the left hand side sequence. We'll find whatever the sequence is, left hand side or right hand side, by the value of the un. If the u of n is having minus n value, then it is a left hand side sequence, and positive value of n denotes that it is a right hand side sequence. For this term, the ROC is z we'll going to calculate first the z transform of this signal. So the z transform of this signal is z upon z plus 1 by 3 and z upon z minus 1 by 2. The resultant is here. And for the ROC, if we're going to calculate, we'll see that two values. One is minus 1 by 3 and 1 by 2. So two circle will be going to draw, and for this term we know that the value, this is in left hand side sequence. Okay, so for this the ROC's mod of z is greater than a. That means the ROC is lesser than 1 by 2. So lesser than 1 by 2, that means we're going to shade the portion lesser than 1 by 2. But for this term we know that the ROC's mod of z is greater than 1 by 3. Here the value is represented by minus 1 by 3, but don't worry. In the previous slide I'll show you, we always mention mod of z is lesser than or greater than mod of a. That means value of a can be taken as positive or negative, that's not an issue, but the area which we are going to cover, that should be marked. So for this question we'll say that mod of z is greater than 1 by 3 but lesser than 1 by 2. So greater than 1 by 3 and lesser than 1 by 2. So a concentric ring will going to form for this particular question. For any finite sequence, here the question is, if the signal is given as a to the power n from 0 to n minus 1, this is having a finite. So for this we're going to use the integrated geometric sum series formula. So integrated geometric sum series formula is clearly tells us that 0 to n minus 1, the formula for the integrated geometric sum series formula is limit n1 to n2 r to the power n will give as a resultant n r to the power n1 minus r to the power n2 plus 1 upon 1 minus r, where r should be lesser than 1. So here the term of az inverse should be lesser than 1. So if after substituting the formula for the integrated geometric sum series, we'll get this answer. The ROC for this sequence is 0 to infinite. This is always a stable system. Now the properties of ROC. So the properties of ROC are, it is a ring or a disk in the z plane which is centered around the origin. The Fourier transform of xn is converge absolutely if the ROC include the unit circle. The ROC cannot include any pole. Yes. Finite duration sequence, the ROC is the entire z plane except possibly z is equal to 0 and z is equal to infinite. For the right hand side sequence, the ROC is extend towards the outermost finite pole if xz to z is equal to infinite. The left sided sequence, the ROC extend inwards from the innermost non-zero pole in xz to z is equal to 0. Few more rational z transform. Here if we'll see, if we will be having a, b and c as a poles, so the ROC will be the maximum value. C is having the maximum value, so ROC is mod of z is greater than c. If the sequence is left hand side sequence, then the ROC will be mod of z is lesser than a, because for the left hand side sequence the ROC is interior and the value of all the three poles which is having the lesser value, the ROC will be lesser than that. So here it is lesser than a. For two-sided sequence, the value lie between the a and b. For another two-sided sequence, here the value is lying between b and c. Thank you for the today's lecture, and our last topic will I'll going to show some formula for the Z transform pairs. Few are the basic Z transform pairs which we have to remember because it is very easy to calculate the inverse Z transform. We are going to discuss the inverse Z transform in our next lecture. So just take a look about this formula, try to remember it, evaluate out, and we will going to start our next lecture from this formula sheet. Thank you.